Students, today I discuss our integration. How an area enclosed by a curve in an interval AB can be found out. So here you have to find out an area which is enclosed by a curve and x-axis. So we have to find out. So we will take a Cartesian plot here. That this is the Cartesian plot, x-axis and y-axis, the origin O. We are taking a curve y, if y is equal to fx. Here we are taking x is equal to a. Here we take the x-axis, x is equal to b. Now we have to find out this area, this whole area. Enclosed by A, B, C, and D point. So y equal to fx is the curve which enclosed area ABCD in an interval x is equal to A to x is equal to B. So how we can find out this? Here we take x is equal to A, this line. So we'll take very small areas to find out the area of the total area enclosed by the curve. So each interval is subdivided into subintervals into each n number of subintervals. And the total difference is BC, which is B minus A. It is further divided into n sub intervals. So if we take the letter side next to the AB, this will be S race, B race. So for the rectangle, for the quadrilateral A, B, B slash, we have B slash is equal to H, and AB is equal to F A S race this race is equal to f a plus h. Now the above portion we can divide into two parts. We can take in this way a short rectangle here. There can be two rectangles. One, if we take the larger rectangle, then the area of the rectangle will be large rectangle it is equal to 8 into a s dash b dash s dash b dash, which is h into f a plus h, and area of the small rectangle is equal to h into eb is equal to h into fa, and later on we can find out in this way. So we'll have a number of such rectangles. If we take the collection or sum of these large rectangles, sum of large rectangles it is equal to summation h tends to 0, summation n is equal to 1 if n tends to infinity, then we take infinite number of subintervals n equal to 1 to n is equal to infinity. Limit of here h tends to 0, we will take h is very small, h into f a plus n h. So this is the collection of the sum of large rectangles. So h is independent of this limit, the sigma is independent of it. So you can write down further summation limit h tends to 0 is summation n tends to 1 to infinity f a plus n h, and sum of small rectangles this will be summation n is equal to 0 to infinity limit h tends to 0, h f a plus n h. Now if we have to take the total area enclosed by the curve A, B, C, D, A, then we have to the limit both the collections have the same limit point. So this limit, this optimum limit and the infimum limit must be equal at limiting value. Then we will get the proper value of the enclosed area. So this will be area enclosed by the curve is equal to limit h tends to 0 summation n tends to n is equal to 0 to infinity will be h f a plus n h. So here we can, in integration form, we can write down limit integration a to b f x equal to dx. So this is the area. We have to integrate fx with respect to the point a to b with respect to dx from the point a to b. Then we can find out the area. So here b is equal to a plus n h. Therefore a is equal to b minus a by n. So as n tends to infinity, h tends to 0. So that's why h tends to 0. As n tends to infinity, h tends to 0. So by this we can take an example. Let's take an example. You have to find out the area enclosed by y is equal to x square, given that the interval EB is x is equal to 1 and x is equal to 5. We have to find out the area enclosed by this curve from the point 1 to 5. So how we can find out the area? So the required area we have to draw a diagram here again. This is the x-axis, this is the y-axis, point origin to O. Now we are taking that x square is in this way will be we are taking x will be always positive, y will be always positive. For any value of x, negative or positive, y will be always positive. So y have no negative value, So this will be the curve. So we will take x is equal to 1. This is the straight line. X is equal to 1. And here we are taking another straight line. X is equal to 5. So by the curve, by the two straight lines, we have the required area. This is, so we can find out this area in this way. The required area will be integration from 1 to 5 fx y, fx is given x square dx. So this will be integration 1 to 5 x square. So we have to take integration. X square integration we know x cube by 3 1 to 5. So this will be 5 cube by 3 plus 1 by 3. So this will be, we calculate, 5 cube will be 125 by 3 minus 1 by 3. This will be 124 by 3. This will be, we divide this, 4, 3 1 is 3, 1, 41, 1 by 3. This square unit will be the required area. So in this way we can find out this area of the curve. I hope you like this video. If you like, then like, share with your friends. If you are not subscribed, then subscribe this channel. Thanks for watching.